And we're talking about methane coming from landfills. And if you have been listening over the last few years, you'll know that there are more and more and more landfills, rubbish dumps, whatever you want to call them, sort of dotted around Gauteng. Some of them are full, and they're just sort of sitting there, festering, basically. But the Energy Systems Joburg Consortium, which is responsible for the implementation of the landfill gas-to-energy Clean Development Mechanism project, which is on behalf of the city of Joburg, plans to submit a bid for 5 landfill site projects under the Department of Energy's Independent Power Producer Procurement Program. And that's a lot of words. It's a lot of, almost unnecessary words. But really what it is it's taking the gas that is produced naturally, the methane gas that is produced naturally, and actually converting it one way or another into energy, into power. And enough power, if all of them come online, all of those 5 landfill sites, to power something like 14,000 houses. So it gets fed into the grid, and it really, really is very special. So we're talking to 2 people, both of them from Energy Systems, and that is Gregory Midlane, who's the project manager. He's in the studio with me, and we're also chatting to David Cornish, who is the director at Energy Systems, and he joins us on Skype, but you shouldn't be able to tell the difference, basically. So both of you, thank you for coming in.
Thanks, Jenny.
Thanks for having us.
Okay, it's an absolute pleasure. All right, so let's talk about this, because with the news coming that we're heading towards load shedding and all of that sort of stuff, which is a concern over the next few years. This is terribly, terribly welcome. And I was just reading that all of the pipes that are needed, all of that stuff is already in one landfill site. Just explain to us what you have to do in order for you to start producing that power, using that gas.
Well, basically, Jenny, we will drill a series of wells into the site at Robinson Deep we already have. We connect those wells up to a series of pipework through a big vacuum blower, which will pump the gas to electricity generators where it's used as fuel. Those generators are then connected via a high voltage cable to the closest substation, either in the city power or the Eskom grid. Basically, to sell the electricity, we are going to be bidding on the government's Renewable Energy Procurement Program. As soon as we have passed all the selection criteria and have been hopefully selected as a preferred bidder, we are then able to sign what's called a power purchase agreement with Eskom, who have set up a single buyer's office. So they basically have a central area where you can sign a contract with, and they do all the administration of power sales and power purchasing through renewables companies. Once we have that power purchase agreement in place, we can then move forward with developing the generation side and the high voltage connection side of the project.
All right. So David, I'm assuming that you must be very, very confident that you are going to get the contract. So you've got one contract, but you've got one to go. Am I correct?
Well, we've got a number of contracts. The Joburg project won't be our first. We've actually got a project that's been in operation and producing electricity for about 2.5 years in Richards Bay. That project's been generating and selling renewable electricity to BHP Billiton, and is developed on a very old closed landfill site. And we've used that as our pilot's demonstration plant to show that the technology is readily available and that we have the expertise to develop it. And we have another of other contracts with private individuals, but the City of Joburg contract is one that's particularly special for us in that it's a large basket of business. We're developing it in partnership with the City of Johannesburg, and it is the single largest basket of landfill gas to electricity projects in South Africa, as you said, totaling about 17 megawatts. And we believe that we are the most advanced in terms of developing it and being ready to qualify under the rebid process. And we have invested significant amounts of money in developing the project, and the only item that we are missing to start investing and developing electricity is the power purchase agreement.
All right, but you must be relatively certain that you're going to get that because you've invested a great deal.
We are, for two reasons. One is the bid process is one of qualification, where you basically qualify your projects and demonstrate that you're ready to produce electricity. And the second one is on price competitiveness. And we understand the market in South Africa and know that A, our projects are ready, and B, we're able to develop the projects based on the price that's been advertised and offered for landfill gas, which is 840 Rand a megawatt hour. And through our financial modeling and our lenders, who is Nedbank, we're able to fund and develop the projects at that price. So we are very confident that we will be selected, and hence our investment in the projects.
All right. So this is the one at the Robinson Deep landfill in Turffontein, and Gregory, I'd just like to ask you. You've already sunk 64 wells. Try and take us through so that the listeners and I can actually understand what is involved, because you've got to get right deep down in order to access that gas which is being produced naturally. Is that correct?
That's correct, yes. What we do is we look at a computer model of the site, normally an aerial view, topographical map, which gives us basically the boundaries and the depth of the site. And we try to drill as many wells into that mass as possible to access as much gas as possible. Basically what it entails is siting the wells approximately 30 to 40 meters apart from each other in a grid layout. We then use what's called, just a general piling rig with a continuous flight auger, which is basically just a big drill. We then drill down towards as close to the base of the site as possible, between 300 and 400 millimeters in diameter a well. We insert perforated pipe into that space, and then fill up the bore annulus, which is the area around the pipe, with stone. So basically that creates a filter around that perforated pipe. Basically what we then do is we connect all of those wells up together, eventually into one large main gas pipe, which can range anything from 250 to 500 millimeters in diameter, depending on the amount of gas. That is then connected into a large vacuum pump. And what we basically do then is we switch the vacuum pump on, and it softly pulls the gas from the site. And what we do is we try to pull with a series of valves, gas meters, and obviously the skills of our technicians on site. We pull the gas off at the same rate that it's being created by the gas, so that if we pull too hard, we can basically suck fresh air into the site, and that will create aerobic conditions, and the methane production will stop. If we don't pull hard enough, that gas can actually migrate off-site, and then that becomes an atmospheric issue, could become a health and safety issue if it migrates into surrounding buildings. So we pull that gas off at the rate that it's being created, and that's basically how it works.
So David, if you're doing that, how long are these landfill areas going to last, or do they vary in terms of longevity? Because you're not in this for the next 6 months or so, are you?
No, certainly not. And I think there's two answers to that question. The first answer is the landfill site has a lifespan of its own. So for Robinson Deep, for argument's sake, I think it's got about 7 years or 6 or 7 years left in terms of the amount of airspace that they can continue to put waste into. Mm-hmm. Once that landfilling process has finished, we are then able to commercially extract and utilize landfill gas from a landfill site for up to 20, 25 years after it is closed and stopped receiving waste.
Okay. So is it degenerating in all that time? When I say degenerating, paper or whatever has been put in there, it's got to be sort of vegetable matter or something
organic
like that
matter,
in order to give you that gas in the first place.
That's correct. It's predominantly it's organic matter. So all the organic matter is getting biodegraded by bacteria. In anaerobic environment. And what we mean by anaerobic is in the absence of oxygen. If you had to put a tomato or an apple on the surface of the ground, bacteria have access to air much like humans do, and will biodegrade the apple and just breathe air normally like we do and produce carbon dioxide. However, in a landfill site, when you've got layers and layers of waste that's been compacted, the air is expelled and the bacteria do not have access to oxygen. So therefore, the bacteria changes from an aerobic bacteria to an anaerobic bacteria, whereby they breathe and obtain oxygen by breaking down water molecules and taking the oxygen out of the water and attaching the hydrogen from the water molecule to the food source, which is basically a carbon. And in that process, they produce methane, which is one carbon and 4 hydrogens. And that's how the bacteria survive. And as they biodegrade the waste, so they produce less and less gas because there's less and less food source over time.
So Gregory, this is not new technology, or is it technology that's existed for quite some time? Because I do know it happens in Europe, and I do know about Holland and Denmark, etc., etc. But is it the latest in terms of a known technology that we're using here in South Africa?
Yes, Jenny, it's the technology, as you rightly say, has been used for approximately 15 to 20, very successfully, yes. 15 to 20 years, UK, Europe, and the States. It is the latest technology which is being used in those parts of the world, which we're going to be using here. And the equipment and the design criteria and everything that we use are the latest of the equipment, etc., that is being used by our UK partner, Energy PLC.
So David, what's it going to look like on the surface, or do we see nothing at all?
Well, there's two things you see. On the surface of the landfill site itself, you will see nothing at all other than a hill, depending on whether it's closed or whether it's still operational, because all the pipes are buried, in particular on an active landfill site, because as you can imagine, there's still a lot of vehicle movement and earth-moving equipment moving around the vehicle, so we bury all of our pipework for its own protection. However, the generation plants themselves are located off the waste for safety reasons and for stability reasons, and they are not a hell of a lot to look at. A 1 megawatt landfill gas generator is packaged inside an ISO shipping container that's painted green with a radiator and an exhaust on the top.
Okay.
So if, to the untrained eye, if you saw 3 or 4 containers sitting in a fenced-off area, it won't look like much. But those are the packaged generators that contain the internal spark ignition engines.
So, if I've got this right, does City Power or the city of Joburg or Pick It Up or whoever is involved, because I guess it's, one feeds off the other, are they going to have to start separating householders' rubbish in order to get the right rubbish into the landfill?
No, they're not. Our calculations and our business model is not based on the separation of waste. And ours predominantly relies on the organic matter. So if the municipality decides to recycle and take out all their tin cans and glass bottles and HDPE bottles as part of a recycling initiative, which we support and endorse, it doesn't have an impact necessarily on the amount of organic and unusable paper that goes into the landfill sites. So the landfill sites will still produce gas. The only item that possibly could reduce the amount of gas that the landfill sites produce is if the city embarks on a wide-scale composting exercise where they're taking a lot of the greens and organic matter that would be going into the landfill site and producing compost out of it. However, having said that, we have not obligated the municipality to continue to landfill, as we understand that is that kind of waste treatment philosophy has a shelf life, and in 15 to 20 years' time that'll be completely different with the introduction of waste to energy plants, recycling initiatives, reducing and reusing our resources as opposed to landfilling them.
Are there other sources of methane? I mean, are there plans afoot to tap into other sources? And I'm struggling to think what other sources there could be. I know you can get methane coming out of bogs and things like that, but what other sources do you have?
We're currently investigating anaerobic digesters, as well as sewage treatment plants.
Yes.
We're in discussion with a number of municipalities to use wastewater treatment plants as a source of methane.
Yes.
But South Africa's also got we're very rich in terms of our coal resources. And in the process of mining coal is naturally heavily laden with methane gas and is normally a bit of a safety issue for mining operations. And we are in discussions with various mining houses to utilize old coal mine works for the methane gas that is venting from those coal mine works, and utilize that as an energy source for producing electricity.
Gregory, I mean, it sounds fantastic because there are all sorts of sources there where you can actually gather the methane and put it to good use.
Yeah.
This is happening in Richards Bay, but nowhere else in the country. Why do you think we've been a bit tardy with this?
Well, there is a development with Durban municipality where they've got 2 of their sites producing electricity directly into their own electrical grid. Elsewhere in the country, the larger centres are developing their projects. They just happen to be a little bit behind the Johannesburg City project for various reasons. And I think it's basically, even though the technology has been used for many years abroad, it's a new technology in South Africa. And it's basically looking just to get those first few cities up and running and successfully producing gas and power and income for the city, and then I think all the smaller municipalities and obviously the private waste companies will follow suit.
What would be the difficulty with using sewage works? I'm thinking of some of the sewage that from failed municipalities, where the sewage goes straight into the Vaal and chugs along in the Hartbeespoort Dam and things like that. How do you manage that, or don't you?
Well, we wouldn't be responsible for management of
No,
the sewage
indeed.
itself,
But I'm
yes.
thinking of accessing the methane if it's floating around elsewhere.
Well, basically, we need to ensure that whoever's managing the sewage in that area has got fully operational wastewater treatment works, and we're able to
Otherwise you can't do it.
Otherwise, we are not able to. No. So basically, it would be a matter of us entering into dialogue with whoever owns and manages those works, and we can obviously offer advice on what they need to do to produce as much gas as possible. Obviously, the more the sewage waste is digesting, the more gas we're able to access, and the more power for the municipality. But at the same time, the better that process is going, the better the plant is actually operating. So it's actually a win-win situation for the municipality.
David, your partner is City Power. How easy or how difficult was it for the two of you to come to an agreement for you to win that part of the contract?
City Power aren't a partner in the project. They obviously part of the project in that they form part of the City of Johannesburg initiative in developing this project. So at this stage, City Power are not the buyer of the electricity. They're facilitating the electrical connection and wheeling the electricity from the sites into their grid as part of the rebid process. Mm-hmm. And perhaps, Jenny, just to answer one of your previous questions as to why aren't there more of these projects in operation,
yes,
is the challenge in South Africa has been that the legislation and the entire market mechanism has been set up around protecting our national utility. And for good reason, if we look at South Africa's history. And it's taken the government a number of years to try and unbundle all of that legislation to create an enabling environment for independent power producers. And that has now culminated in the rebid process, where government is facilitating bids from independent power producers to develop their projects. And that, over the last, I would say, 10 years, has been what has really held back the renewables industry as a whole, but also in particular landfill gas and methane utilization projects. Because we've had projects that have been ready to go to commercial operation for more than 2-3 years, but haven't had the enabling environment and been able to sell the electricity through a power purchase agreement is what has really held them back. And now with the rebid process out, that kind of key to unlock the door is now available.
Well, look, it's a win-win situation for the city, isn't it? Because you're coming up with the 250 million development money that you've got to, and the city is going to see the benefit of that.
Yes, they'll see the benefit in more than one sense. Obviously, the communities will see the environmental benefit in the reduction of odours and greenhouse gases escaping from the landfill sites. The country as a whole will see the benefits in that we're registering the projects as clean development mechanisms, so we'll get the reputational benefit from that. And then the city also shares in the revenue generated by the project. So for the city, it really is not only environmentally, socially, and financially beneficial. It also increases the stability of the landfill sites, and indirectly increases the efficiency in which they operate the landfill sites, because you need to manage the landfill site in a very specific manner for the landfill gas project to be successful.
So how old does the landfill site have to be? I mean, the way you're describing it, the stuff at the bottom is nicely rotted, it's letting off the gas. The stuff at the top has still got to degenerate, decompose, etc., before you can get methane off it. So you can't start doing this, I wouldn't have thought, with something that was 1 year old. So give us an idea of how old it's got to be.
Funny enough, landfill gas is produced as early as 6 months after the waste is landfilled.
Okay.
So the gas production actually starts quite early. The trick with landfills and why people perceive that you need to wait a long time before you can start is it's purely based on a volumes basis. You need a significant volume of waste producing gas before a project can be viable. So you would need a landfill site, whether it's received the waste in the last 6 months or in the last 3 years, to have somewhere in the order of 3 to 5 million tons of waste in position in order for it to be generating significant amounts of gas for you to then to develop a project.
Gregory, your project manager, does this have any bearing whatsoever on acid mine drainage?
None whatsoever.
None.
Jenny, no.
Because, I mean, I was thinking, wouldn't it be wonderful if somehow or other you could tap into that and help to ease that problem? Because we haven't come to terms with it yet.
No, very much so. If we could, we would love to assist in reducing that problem.
But there's no synergy
none
whatsoever.
whatsoever.